For this problem, we're going to solve this trigonometric equation by using the inverse functions, and then we have to take into account the fact that we're finding all the solutions for theta between 0 and 2 pi. So generally, when we're working with a plane function, sine theta, cosine theta, what have you, you're generally going to get two solutions to this. So that's what we're going to see here. Now, why am I getting two solutions? The reason why is because theta is some kind of angle, and it's an angle that when you take the sine of it, you get a positive value. And so what that tells me is that theta is either in quadrant 1 or it is in quadrant 2, because those are the two places where the sign turns out to be positive. So I'm going to go ahead and take the inverse sign of both sides of the equation. So that means I have sine inverse of the sine of theta, and that's going to equal the sine inverse of 0.49. And I'll pop that into the calculator. Now when I pop this into the calculator, what I got for the sine inverse of 0.49 is 0.5121. And I'm going to go out 4 decimal places because I don't remember how many they went on the problem. Let's see if I can find it. Oh, it says 2 places. All right. Here we go. And when I take the sine inverse of sine theta, of course what I'm going to get then is just theta. So I've got theta equals 0.51. And this is in radians, and the reason why I know that I need to be in radians is because they told me theta is between 0 and 2 pi, and that's in radians. There's no degree symbol, and we know that when you see a pi, chances are that we're talking about radians here. So we've got 0.51. It looks a little different from the traditional ones with pi over 3 and pi over 4 and so on. It just didn't happen to come out that evenly in this problem. And the fact that these two values happen to add up to 1, just a coincidence, not really related in that way, just happened to come out that way. All right, so what I do know then is that theta is 0.51, and I know that another possibility for theta is in the second quadrant. So what I'm going to do is I'm going to draw the mirror image here, and so then the question is, what is this angle? If this was 0.51, then what I'll do is I'll take pi, right? This would be pi, and subtract 0.51 from pi and see what value I get. So when I take 3.14 minus 0.51, then I get 2.63. So that's what I've got for my two solutions for this particular problem. So theta equals either 0.51 or 2.63. And that's my first solution there. Now in the next problem, we're going to work with cosine. We're also going to take a look at some negatives. So I want to solve cosine theta equals negative 0.04. And again, we're solving on 0 to 2 pi, so we're working with radians. Now, where is the cosine function negative? That's what my question is here. The cosine function is negative where the x value is negative, and so that's going to be on the left side of the graph. So theta could be in quadrant 2, or it could be in quadrant 3. It's not in quadrant 1 this time. So on the graphing calculator, I'm going to take the inverse cosine of negative 0.04. And when I did that, I got 1.61 and then a little bit after that. So we're looking at an angle that is in quadrant 2, and I can tell that by just taking pi divided by 2, and so that's 3.14 divided by 2, and that's going to come out to 1.5 and change. So 1.6 is going to be a little bit bigger, so that's in quadrant 2. Now I have to find the corresponding angle in quadrant 3. So the question is, how far is it to get to here? Well, what do I know? I know that, let's see, this would be 1.61. And what I can do is take 2 pi minus that 1.61. That's one way of solving this. And I can just bang that into the graphing calculator and see what I get. And so what I get is 4.67. So the two solutions for this equation are 1.61 and 4.67. That's the end of that problem. Now let's take a look at a third problem involving tangent. We've got 9 tangent theta plus 8 is equal to 0. So I'll start off by solving this just as a regular old linear equation, and then when I get to tangent of theta equals whatever, then I'll go ahead and take the inverse tangent of both sides. So I've got 9 tangent theta plus 8 equals 0. I'm going to subtract 8 from both sides, and I get 9 tan theta equals, negative 8. And I divide both sides by 9. And tangent of theta equals negative 8 over 9. All right, so now I can take the inverse tangent of both sides of this equation. And when I do this on my calculator, I get theta equals negative 0.73. So we know that the tangent is equal to a negative value, and so we wound up with theta equals negative 0.73. And so what is it that I have to do with that? I'm going to change it because I am only allowed to have x between 0 and 2 pi, and this is a negative. It doesn't work. So if I were looking at negative 0.73, which is in quadrant 4, I don't know, something like that, I could look at the corresponding angle in quadrant 1, which is 0.73. And I know that this is no good. The reason why it's no good is because in our problem, we had tangent of theta equals a negative 8/9, and this would be when tangent of theta equals a positive 8/9. So I'm going to go over to quadrant 2, and I'll draw the corresponding angle there. Okay. And if this was 0.73, then this would be 0.73. And so what we really want to know is, what is this angle? Well, I know altogether from here to here is 1 pi. So if I take pi minus the 0.73, that will give me the angle that I'm looking for. And so I got theta equals 2.41, or then I have to find the other possible value of theta. And we've actually already kind of looked at it, and here it is right here, except we really don't want this negative angle. Again, theta has to be between 0 and 2 pi, but what if I go all the way around to there? So now I'll be between 0 and 2 pi for sure. So how do I figure this out? I'm going to take 2 pi minus 0.73, and that will give me the remaining portion of the angle. So I'm just putting that into my calculator. And I get 5.55. So 2.41 or 5.55, and that's how we solve that problem.